As a business hires more people and plugs in more devices, the company network will often go from lightning fast to a sudden crawl. The underlying cause is usually how the network is laid out. When every department is grouped onto a single, flat network, every computer has to process the background chatter of every other device in the building. Today, we are going to fix that. We'll take a congested flat network, physically rewire it to separate the departments, and route the traffic between them so you can see the exact efficiency gains. Go ahead and open Cisco Packet Tracer and load the activity file 14.3.3 to follow along. Learning how to spot and eliminate this kind of congestion is the exact process network engineers use to build reliable, enterprise-grade infrastructure. Let's look at this animated diagram of our starting topology. Right now, accounting, finance, and sales are all daisy-chained together on one continuous loop. To see why this setup fails at scale, we need to generate some traffic. Open the command prompt on the Sales1 host and type arp-d to clear the ARP cache. Wiping that cache guarantees that the very next time this computer tries to talk to another device, it will have to send out a fresh ARP request to find it. Click over to simulation mode in the bottom right corner. This lets us slow down time and track the individual packets moving through the cables. Now, open the command prompt on Sales2 and ping the IP address of Sales1. Click the Capture then Forward button in the play controls to step the packet out of the host. Inspect the packet envelope contents. Look closely at the destination MAC address. It is filled entirely with Fs. That string is the universal broadcast address. It tells the switches to duplicate this packet and send a copy down every cable in the building. Since every ARP request acts like a megaphone, a network with 150 devices generates a massive amount of background noise. The switches spend so much time processing these duplicates that actual data gets delayed. To stop the flooding, we have to break the lateral connections between these departments. Switch your workspace back to real-time mode so we can make physical changes. Select the copper straight-through cables connecting the accounting switch to the finance switch and finance to sales and delete them. Instead of daisy-chaining them, draw a new cable from each department switch straight up into an available gigabit Ethernet port on the edge router. The hardware paths are now separated, but the computers still think they belong to a single group. We need to assign them new IP addresses to logically divide them. Open the command prompt on the individual machines located inside the finance and sales networks. Type ipconfig/renew. This forces the computers to contact the DHCP server and request an updated address. Notice the newly assigned IP numbers. The router assigns a distinct IP range to each port. Finance receives a completely different subnetwork address than sales, confirming they are logically isolated from one another. Let's test if our isolation worked. Go back to Sales2 and run the arp-d command one more time to empty the cache. Switch the workspace back over to simulation mode so we can track the traffic. Ping Sales1 from Sales2, exactly like we did earlier, and hit Capture then Forward. Watch the ARP request flow this time. It hits the sales switch and only copies to local computers within that subnet. One copy travels up to the edge router. Since routers do not forward broadcasts, it drops immediately, protecting accounting and finance. On the left is the flat network we started with, choking on its own requests. On the right is our routed setup, where traffic remains neatly contained. By segmenting the network, the router acts as a barrier against background chatter. Switches can now dedicate their full bandwidth to moving actual data. You've successfully taken a sluggish, unified LAN and rebuilt it into an efficient, routed network. In networking terminology, we just created separate broadcast domains. A broadcast domain is simply the boundary that traps noisy all-points bulletins and keeps them from spilling over into the rest of the building. While we used physical cables in this demonstration, modern enterprise setups often achieve this exact routing logic virtually, using VLANs and Layer 3 switches to assign domains without moving a single wire. Save your packet tracer file. For an extra test, try pinging the external ISP to see how your routed traffic leaves the internal network entirely. Controlling where broadcasts can and cannot go is a core principle of network design. By mastering broadcast domains, you ensure that a business can add thousands of new devices without dragging its operations to a halt.
Good morning, good afternoon, good evening. This is Professor Sistrunk, and I'm reaching out to the student body. Okay, students, we finna complete this lab called 14.3.3 Packet Tracer. Observe traffic flow in a routed network. So now you get an opportunity to work with routers in a routed network. And one of the most important things in this particular lesson is to learn what is the objective of this particular lesson. The objective, if we look at the title, really tells you everything. Observe traffic flow in a routed network. So what we're trying to do is see how do traffic flow from one point to the next point. Okay, so now let's take a look at the learning objectives of this particular packet tracer. So we see here, observe traffic flow in a non-routed LAN, reconfigure the network to route between LANs, observe traffic flow in a routed network. This is mission critical. All you really trying to do is see how traffic flows. You're not trying to learn how to configure the network. You already got that down. You doing that in a step-by-step process. What you're trying to do is see how traffic moves from one location to the next location. And sometimes you get bogged down when you don't see everything work 100%. But that's okay. That's what I'm here for. That's why they pay me the big bucks. Now let me stop playing. Let's go. Let's go. Let's go. So sometimes we have to take a look at the assessments. Now, looking at what actually works in here, you see you got multiple things. Now, a lot of students email me and say, hey, Professor Cisco, I couldn't get this to work. What is your purpose? Was your job to get all of these to work? Yes. But the main purpose of this assignment is not to get so bogged down with this, because if you're in the IT industry, and I have quite a few of you in here, when something doesn't work, we know we escalate it up. Remember that word, escalate it up. Now that do not mean I'm gonna try it once, it didn't work. You tried once, you tried twice, you tried a third time, everything else is working and you doing it exactly the correct way, then you escalate it up. And I'm here to say a lot of you understood that. You sent the assignment, you posted your assignment, and you left comments in there that Finance 2 is not correctly working. That's what we do in our industry. When things don't work, we escalate it up. But let's take a look at this assignment and go into it and see how this assignment works. So we're back at the assignment. Okay, so the first thing we know that we have to do is we have to move the needle on this particular assignment. And you can see right here that we have on our network. And we see that this network can cause multiple problems. So what we're going to do is start analyzing how traffic flows in this particular network. So we're going to go to sales, and in the process of sales, we're going to click on desktop, and from desktop, we're going to go to command prompt. Now you can see that the IP address in here is 192.168.1.4. Okay, I just wanted to look at that, and then we're going to go to command prompt right here. We are on sales 2. So I'm going to close that and go to sales 1. Now, the reason I came here is I wanted to make sure I can see this IP address. It's a 4. Okay, now we're going to go back to sales 1, and we're going to click on desktop, and we're going to go to the command prompt. And the first thing we're going to do is clear out all of the packets if there was some. So if I type in ARP-A, and then ARP, you can do ARP-D, D to stop it too. You can see there's no traffic going on. I did A first because I know I just opened this up. But if it was traffic going on, I do ARP-D to delete any traffic that's happening. Okay, so we resolved that particular issue. We're gonna close this here. and I'm gonna look at the IP address in here. This is a 7. Okay, so we're gonna close that. Now, the next thing we're gonna do is open up simulation mode. And don't worry, I'm gonna make this short because I want you to watch it. In simulation mode, we're gonna go ahead and go to the command prompt in 2. So I'm gonna go here, and then I'm gonna go to desktop, and I'm gonna go to command prompt. Now I know I'm gonna go ahead and do a ping right here. I'm gonna go ping 192.168.1. And if I was correct, that was 7. Okay, I'm gonna go ahead and hit enter, but I'm gonna start doing this to show you what will happen. Now you see traffic is going everywhere. This is what slows a network down. And I'm gonna bring that closer so you can see it. Traffic is everywhere, and we don't want that in a network. Okay, so the first thing that happened, and I'm gonna go back and do it again. The first thing that happened, we sent packets everywhere. We want to send the packet directly here and directly to there. We want to go from sales 2 to sales 1, but we don't want to send traffic everywhere. So I'm gonna do that again so you can see it. I'm gonna go ahead and clear this out again. Let's do that again, please. I'm gonna go to, I thought I put it in here. Well, let's do it again. We're gonna go R-D and do that. And then I'm even gonna put A in there too. I like to just go ahead and do A anyway, just to show that it's nothing in there. But I'm also gonna go over here to sales 2. Okay, and this is what we mean by cluttering the network, bogging the network down. We don't want to do that, so we use these to make sure that we don't have collisions, people, collisions. Now we're gonna bring simulation mode back up. We're gonna bring that up, and since we already have the IP address in there, we're gonna go ahead and run it again. And watch this first one. You're gonna see it's going there, and then it's gonna break off to everywhere. We do not want to have that happening. You see, that is a major problem. So you get the point on this. We don't want collisions. This causes collisions. And it also is a security risk because people can start seeing what's happening with our network. So the next thing I want to do now is I just want to make some changes. I'm fast tracking this, so I'm not going to do everything. I'm fast tracking it. I'm going to come here and do this. I'm going to click on this here and get rid of that, and then get rid of that. And then I'm going to come back and get this pointer here, and then I'm going to come here. And of course, I'm going to get me a crossover cable. I'm going to click here. Of course, I'm going to go to Gigabit Ethernet, and then I'm going to click here and get Gigabit Ethernet, if I'm saying it right, G1, G4, whatever. Okay, moving right along, I'm going to go here, get this, and I'm going to come there, and then I'm going to click here and get that. Okay, I'm going to do my fast track so I can speed it up. Okay, we looking good, but I got to go clear some things out. You know that I have to release and reset. So I'm going to come here and say IP config. And then I'm going to say /renew. Okay, renew. Hit O. Did I spell that right? Yeah, I did. And we got that cleared. I'm going to close that. And then I'm going to come to this one and do the same thing. Well, no, right here and do the same thing. I think I'm in the right place. Since I only changed that, I'm going to say IP config. And I'm going to say / and I'm going to say renew. Okay, we know we got to do renew. And there it is. This should turn out right. So we renewed it. Okay, so I renewed it on these two connections here. Okay, and if I put my mouse pointer here, you will see I got 192.168.1, 2, and 3. And that's what should come to these IPs. Now, I can go in here and simply just check and see if I got that IP address. I'm going to go down here. Well, I see it right there. There it is right there. 192. That's 32 right there. Well, let's go see what this one say. Okay. So I'm going to come right here. I'm just looking at the IP addresses right now. This wasn't part of the lesson, but I'm going to go ahead and just say IP config. Okay, see what I got. And I see that that has a 1. That should not have a 1. So I'm going to go ahead and space and say /renew. Okay, let's see what we got now. Okay, that is 33. So we changed that. Let's see if that was on sales 1. Let's see if finance 1 has the same thing. I'm going to click on there and come here. And then I'm going to say IP config wait a minute, I gotta say / see, renew. Okay, let's hit it, see if it works. Okay, that is 23. Okay, so we got that. So we were able to make changes to this. We got this here renewed. Let's make sure we got that renewed. We got that renewed. We got that one renewed. So everybody is straight now. Now we're going to open up simulation mode again. And we're going to click here. And here we go. Okay, so I'm going to go ahead. Now, remember, I'm pinging from here to here. I should have a packet go here and there. And I should have a packet go here and here. I should have it go over to these two here. So let's see if that happens. Let's go ahead and open this up. Let's go here. If I remember, wait a minute, I got to check and see what that IP address was. What was it? It was .3.3. Okay, so I got it now. You got to check them IP addresses because you could forget. So I'm going to go ahead and do a ping here. I'm going to say ping 192. If you're with me, 168.3.3. If I'm correct, let's see if it works. I'm going to go ahead and click it. There it goes. It's going up. Click it again. It goes there. Click it again. It goes up. Click it again. That's what should happen, people. We got that. And I know you guys already know it. You're saying right now, Professor, I understand this. What are you talking about? But here is the thing. Let me go ahead and check the results. So we're checking the results right now. Okay, let's see what we got. Okay, we got this correct, that correct, that correct. Well, Professor, but that wasn't the point. I know you saying, Professor, that should be correct. But we wasn't doing that one. We was observing. Remember, people, we were observing. Now, if this incident happened for real, in real world, and you could not get it to change, all you would do is, what's that magic word? Escalate it up. Everyone will get credit for this, but you will escalate it up. Let's go ahead and close. So we solved the problem and we looked at the lesson. That's all it was. Don't worry. You will get full credit because you escalated it up to me and I was able to view the issues and the problem.